The last photograph ever taken on Venus shows something that shouldn't be there. Not a rock, not a malfunction. Something that wasn't in the frame before and was gone in the next one. The Soviet engineers said it was a piece of the lander that fell off during impact, but the position doesn't match, and they never explained why it moved. This is the last signal Venera 14 ever sent, and what it recorded in those final minutes before being crushed and melted by Venus has never been fully explained. Venus is the closest planet to Earth. At its nearest point, only 61 million kilometers away. Close enough that on a clear night you can see it with the naked eye, the brightest object in the sky after the moon. Ancient civilizations called it the morning star, the evening star, a beacon. What they didn't know, what nobody knew until we actually sent machines there, is that Venus is not a beacon, it's a warning. The surface temperature is 475 degrees Celsius, hot enough to melt lead, hot enough to destroy any machine ever built within minutes. The atmospheric pressure is 92 times greater than Earth's, the equivalent of being 1 kilometer underwater, except instead of water, it's superheated air laced with clouds of sulfuric acid, the same acid inside a car battery. And yet, for 2 decades, the Soviet Union kept sending probes there. Not because they didn't know how dangerous it was, because they did, and they sent them anyway. The question nobody asks is why they stopped. The official answer is economics. The Soviet Union collapsed. NASA couldn't justify the cost. But the last images Venera 14 transmitted before going silent contain something that the official reports mention only briefly, and then move on from without explanation. Something moved. To understand what the last signal means, you need to understand what it took to get there. The Soviet Venera program launched its first probe in 1961. Venera 1 and 2 both failed before reaching Venus. Total system failures before they could return any data. The engineers went back to work. In 1967, Venera 4 became the first spacecraft to enter the atmosphere of another planet and transmit data on the way down. What it found changed everything. At high altitude, the atmosphere of Venus was almost pleasant, comparable to a warm summer day on Earth. But the lower the probe descended, the more extreme the conditions became. Not just temperature, pressure. The air on Venus doesn't behave like air. It behaves like water. Dense, heavy, crushing. After 90 minutes of slow descent, the transmission went dead. The capsule had been crushed like a can. The Soviets already knew the next probes. Venera 5 and 6 would face the same fate. They launched them anyway. Both confirmed the nightmare. Less than an hour of data each before the atmosphere imploded them. But the Soviets didn't stop. They built stronger, thicker steel casings, internal titanium spheres to protect the instruments. And they tried again. Venera 7, August 1970. The parachute failed, ripped or melted on the way down. The lander fell at 60 kilometers per hour and hit the surface hard. Back on Earth, the scientists assumed it was over. Another failure. But the signal kept coming. Damaged antenna, distorted transmission, but alive. And what Venera 7 recorded before going silent was the confirmation of everything they feared. Surface temperature, 475 degrees Celsius. Hot enough to melt lead. Hot enough to destroy any machine ever built. And yet the Soviets still didn't stop. Because Venera 8 revealed something that made the risk worth taking. Even through the thick cloud cover, enough sunlight reached the surface to take a photograph. For the first time in history, a camera could survive long enough to photograph the surface of another planet. But what those cameras would eventually capture, in the last transmission Venera 14 ever sent, is something the official record describes in one sentence and never returns to. And that one sentence is the reason this video exists. Venera 9 landed in 1975, the first photograph ever taken on another planet's surface. What it showed was a field of sharp, jagged rocks surrounded by a sandy material. Not spectacular, not alien in the way science fiction promised, just rocks, on a dead world under a yellow sky choked with acid clouds. Venera 10 landed days later in a different location, flat ground, smooth volcanic formations, ancient lava flows frozen in place, 2 landing sites, 2 completely different landscapes, both hostile beyond anything ever built to survive them. Venera 11 and 12 failed to return usable photographs. The lens cap systems, designed to protect the cameras during descent and then retract automatically, didn't work. The cameras melted before they could see anything. Then came Venera 13, 1981, the mission that changed everything. The first color photographs of Venus. And for the first time, humanity saw the surface of another world in full color. Orange-brown rock, dark soil, a yellow sky pressing down like a ceiling. The probe carried a drill. It analyzed the surface composition, solidified volcanic ash, basalt, the same material that makes up the floor of Earth's oceans, and it carried a microphone. For the first time, we could hear Venus. What the microphone recorded was wind, the sound of the probe operating, mechanical sounds in an atmosphere that no human being has ever breathed and never will. There is something deeply strange about hearing another planet, even if what you hear is just noise. Venera 13 survived 127 minutes before the heat and pressure destroyed it, the longest any lander ever survived on Venus. Venera 14 landed 4 days later. Different location. Same hostile environment. Same 57 minutes of operation before going silent. And in those 57 minutes, Venera 14 took 14 color photographs and 8 black and white images. A panoramic view assembled from those images became one of the most studied photographs in the history of planetary science. Because in that panorama, between one frame and the next, something changed. The Soviet scientists who analyzed the images identified several objects in the landscape they couldn't immediately explain. Objects that appeared in one frame and were gone, or in a different position in the next. The official explanation was given quickly and without much elaboration. Debris from the lander itself, dislodged during impact. But a team of researchers from the Russian Academy of Sciences Space Research Institute published a paper years later that examined those objects in detail. And what they described doesn't match debris. The objects the researchers identified appear in multiple frames of the Venera 14 panorama. One resembles a disk. One resembles a dark cloth or membrane. One resembles a scorpion. The researchers were careful in how they framed their conclusions. They didn't claim life. They claimed anomaly. Objects that appear and disappear between frames. Objects whose movement cannot be fully explained by the lander's own displacement or by wind at surface level, because the atmospheric pressure on the surface of Venus is so extreme that wind at ground level moves at only a few kilometers per hour, not enough to move anything of that size that quickly. The paper was published. It generated discussion in specialized circles, and then it was largely set aside. The official position remains: debris from the lander. But consider what debris from the lander actually means in this context. Venera 14 hit the surface at speed. The impact ring absorbed the blow. The probe was designed to survive impact and function immediately after landing. The 57 minutes of data it returned confirmed that it did function. Cameras, instruments, transmitters, all operational from the moment of landing. If debris was dislodged during impact, it would be in the first frame. It would stay in subsequent frames unless something moved it. The objects in question were not in the first frame. They appeared. And then they were gone. Venus is almost exactly the same size as Earth. Almost the same mass, almost the same density, almost the same gravity. In the early history of the solar system, Venus and Earth formed from the same material, in the same region of space, under the same conditions. Whatever process led to life on Earth was also available on Venus for billions of years, before the greenhouse effect accelerated beyond any point of return, before the oceans boiled away, before the atmosphere became what it is now. Venus may have been habitable. Some models suggest it could have maintained liquid water on its surface for up to 2 billion years. 2 billion years is longer than it took for complex life to emerge on Earth. We don't know what was on Venus before it became what it is now. We do know that on Earth, life survives in conditions that were previously considered impossible. Bacteria living in environments with no sunlight. Organisms thriving in sulfuric acid concentrations that would destroy most life. Extremophiles that exist in temperatures close to what we find on the surface of Venus. The question of whether something could survive on Venus today, not on the surface, but in the upper atmosphere, where temperatures and pressures are closer to Earth's, is not a question that has been definitively answered. In 2020, a
a team of astronomers announced the detection of phosphine in the atmosphere of Venus. Phosphine is a gas that, on Earth, is produced almost exclusively by biological processes. The announcement was controversial. The data was disputed. The detection was partially retracted, then reanalyzed, then disputed again. No consensus exists. What exists is an unanswered question.
The last probe to reach the surface of Venus did so in 1985. Venera 13 and 14 were the last to return images. After that, the program shifted to radar mapping from orbit. No more landers, no more cameras, no more microphones recording the sound of a world slowly destroying the machines we sent to look at it. The official reasons are straightforward. The Soviet Union began its collapse in the late 1980s. Resources evaporated. Priorities changed. The program ended not because of a decision, but because the institution that ran it stopped existing. NASA has never attempted to land on the surface of Venus. The justification is practical. The longest any probe ever survived was 127 minutes. The cost of designing, building, and launching a mission for 127 minutes of data is extraordinarily difficult to defend to the committees that control funding. So we stopped. For 40 years, the surface of Venus has been completely silent. No machine has touched it. No camera has photographed it. No microphone has recorded its sound. Whatever is in those last images, Venera 14 transmitted, whatever moved between frames in the final minutes before the probe was destroyed, remains exactly where it was. We just stopped looking. Here is what we know with certainty. Venus is the most Earth-like planet in the solar system. It formed under the same conditions as Earth. For a significant portion of its history, it may have been habitable. It currently has an unexplained chemical signature in its atmosphere that, on Earth, would indicate biological activity. The last images ever taken on its surface contain objects that moved between frames in ways the official record explains in one sentence and never revisits. And for 40 years, no government on Earth has sent anything back to find out. Not because it's impossible. NASA has approved 2 missions, DAVINCI and Veritas, both targeting Venus, both facing delays, both not yet launched. Not because we've lost interest. The phosphine detection in 2020 generated more scientific attention to Venus than the planet had received in decades. Because landing on Venus and surviving long enough to answer the question is still, with current technology, extraordinarily difficult. The surface will destroy anything we send within hours, which means the question in the last signal Venera 14 sent, the question of what moved in those final frames, remains open. Not because we answered it, because we stopped being able to ask it. Venus is visible tonight. If you go outside after dark and look west, you'll see it. The brightest point of light in the sky after the moon. The morning star. The evening star. What ancient civilizations used to navigate, to mark seasons, to build calendars. What they were looking at, without knowing it, was a planet where the ground temperature melts lead, where the atmospheric pressure would crush an unprotected human body instantly, where clouds of sulfuric acid circle the globe in 4 days at 360 kilometers per hour. And somewhere on that surface, under those clouds, in that heat, under that pressure, there is a piece of Soviet machinery that stopped transmitting 40 years ago. In its last frames, something moved. We called it debris. We moved on. But the question that Venera 14's last signal opened has never been closed. And it won't be. Not until something lands on that surface again and looks at what was left behind. The next mission to Venus is still years away. Until then, whatever was in those images is still there, in the dark, under 92 atmospheres of pressure, waiting.